Got an iPhone 12 here today that does not turn on. So let's see what's going on as far as power consumption. Go ahead and plug in our trusty little ammeter here. And when we plug in the charger, got nothing. Oh, did you see that? Keep an eye right there. Let's get this thing focused. And you'll see what happens is we very briefly get a 0.45 amp, 0.44 amp reading before it goes down to 0. And that is often indicative of some sort of short in the system. And it's getting 0.14, 0.19. 0.28, that's interesting. 0.19 again. Huh. Alright, well, let's open this up and see what it looks like on the inside. Okay, so far I've disconnected the battery and removed the display. Just kind of taking a look around inside of the housing, and I haven't seen anything in the way of liquid damage or physical damage yet. I did notice down here that it looked like maybe the battery, I don't know if that's been removed and replaced or what's going on with that. No big deal. This may be from the alcohol that I used to open up the phone. But yeah, nothing really jumping out at me. You can see the liquid damage sticker here is still white. And if we take a look down inside the charge port, you can see a little debris, signs of use, but none of the pins are missing. I don't see corrosion just yet. Whoops, let's get this back in the frame. Really zoom in here a bit more. Yeah, it just kind of looks dirty, really. You can't zoom too much and keep light on this thing, though. Alright, so first thing we'll do is check at the battery terminal and see if we're even getting power, which I imagine we're not. I wouldn't expect to. So I'm going to plug in the charger, and we'll put the meter on screen. You can see if we get any voltage. Alright, so yeah, it's very short, very small draw, and then it goes away. So yeah, something in here is preventing power from getting to the charging system. So I'm going to try a different charge port just to rule that out. And we'll see if that does any good. And looks like the same thing, so I think we're going to need better tweezers too. And this is probably not where we're going to find anything, but I'm going to check anyways. Well, whatever that is, it's interesting. So that is VDD main, and it is showing completely shorted straight to ground. So we have an idea where our problem may lie, and unfortunately on this phone everything is either inside between the layers or it's covered by a shield. So we could have some components, let's see, basically anywhere underneath one of these shields. There's a couple coils here, but that doesn't really help us. So basically we could be looking underneath this shield or on the inside of the on the inside of the two boards, between the two layers. And the question is, do we want to pull this off or do we want to split the board? Because we are not going to be able to detect any heat without doing one of the above. For this project, I am using the iRepair Universal Desoldering Platform. I actually like this product a lot, and I'll do a video on that later on. But what you'll see here is that I'm just kind of testing the corners as I heat this up, which doesn't take very long with this platform, by the way. So you get things melted, take them apart, get them off as soon as possible. And in my experience, that's the best practice. So I'm just going to let the video roll here, and you'll see momentarily that this thing gets warmed up enough to separate. So what we're going to do next is just install a jumper wire here at our VCC main test point. And I was able to detect heat with the thermal camera right here. I'm going to go ahead and use some free spray so that you can see that as well. So just keep your eye on that capacitor right there. We will spray this down with some free spray, and as soon as we inject 4 volts into that line, you will see exactly where our problem is. Alright, so our next task is to remove and replace that capacitor, and hopefully once we do that, we will have a clear line. Unfortunately, my microphone was turned off, but this did in fact end up being a shorted capacitor, which we kind of already knew. But more importantly, when I check the VCC main power rail here, we are clear. We have a good value with the multimeter, so we are ready to replace this capacitor and get the phone back together. Now before we go too far, we'll join the boards together using a specialized jig that does not require us to melt the solder, and then it'll allow it to make contact between the top and bottom boards. We've got the battery, the charge port, and the display plugged in so that we can just test the essentials and make sure that this thing is actually going to power up. And once we do that, and we know that it seems to be working, then we can go ahead and get it ready to reassemble after we go through the reballing process, which will be the next step. And of course the battery's dead, so I'm going to step away from this for a minute, and we'll come back. Hopefully we'll catch it turning on, and fortunately we did. I'm going to cover this up just in case there's any personally identifiable information on the screen. And it looks like we've got a wallpaper and of course the passcode, so nothing to see here, but at least we know that the phone does boot up and the touchscreen is functional. I'm going to spare you the majority of this process because it takes a while, but anyways, what we're going to do is we're going to go around the top layer of the board. We're going to add some leaded solder, and then we're going to clean off all the factory solder to make it so we don't have to get both of the boards as hot as we would have to if we left the original stuff on here. And it's also just it's not good really for the phone. I don't know why they chose to use such a high temperature or a high melting point solder on this. Everything up to the 11 Pro Max, we can basically just use the existing solder, but unfortunately on the 12 and forward, it seems to make a lot more sense to replace it with leaded. So what I'm going to do is let this iron heat up. We'll add some solder, we'll wick it away, and I'll just show you one section because this is a long and boring process. Okay, so that'll make it a little easier to remove, and we just come across with the clean iron. That's the idea. And we'll get all this old stuff removed. So now we'll have a nice clean surface to work with. And like I said, this is just going to make it a lot easier to get these two boards to go back together without any issues, assuming they are completely straight. So that's what we want to end up with all the way around the perimeter, and then of course down in this section here, which is always fun to get to. Going to need kind of a smaller iron. And then we're going to do the same with this interposer section here. I'm going to clean all of the solder off of this one and pretty much use the same process. Then we get to go back and reball this whole thing. Let's see, where are we? Okay, so we'll go across here, we'll put some lead on here, clean it off, and I'm sure you get the idea. So that is what we're looking for on this entire thing. And now comes the fun part. So we're going to put this little reball stencil on top of here. I actually like this set as well. It has a magnet built into it, several magnets actually, that will hold this thing down. But you'll notice during the process that it does lift up in a couple different places, so it's less than perfect. I'm experimenting with some different types of reballing stencils for that reason, but for the most part this one worked out pretty well. There were a few places I had to go back and touch up, so that's kind of a bummer, but I'll demonstrate the process here and hopefully you'll find this helpful. I'm going to do a full tutorial eventually on just this step because there's quite a lot to it. It does require some practice, and you really have to have the right consistency with your solder paste. I've found that that's one of the most important things. But as you can see, this thing kind of just moves around a little bit. And like I said, it warps, it likes to lift up, so it's not perfect, but we'll get it pretty close. Now this is one of the things that you have to kind of experiment with. Like I said, if the solder's too wet, if the solder paste is too wet, you're going to have issues, and if it's too dry, you're also going to have some problems. So you just kind of have to play with it a little bit. I'd recommend doing a small section until you feel very comfortable that you've got the right consistency, and once you do, you'll know, and then you can go through, spread it all over this, and hopefully get it off. Lift up the stencil without pulling any of the solder paste away from the interposer board, which is where it needs to remain. So as you can see, as I lifted that up, most of the solder paste stayed where it's supposed to be, which is on the contact points that we're going to want it to melt. And this is kind of the cool part for me, is when you put this on the hot plate and you warm it up, you can actually see these things melting and bonding into the right spot. And even though they're off a little bit there, that won't be a huge issue. As long as they're still making contact with each of these little discs, they will actually melt and pull themselves into place. Now, if you watch closely, you'll notice right about 180-ish, when it hits that temperature, that these will start to melt. And it usually starts at the top end of the motherboard for whatever reason, and then they just kind of spread and go all the way down to the bottom. So I actually hit about 190 on this one, but you can see they're starting to melt now. Now as we inspect the perimeter of the board, you'll notice there are a couple of faults here. There are two right there, or actually there's about, let's see, 5 pads there that kind of ran together. So you want to make sure that you check these, that they're roughly the same size and the same height. I've got some messes over here too. Like I said, sometimes that stencil likes to lift up, or I wasn't pushing down hard enough, but fortunately that's not a deal breaker. You can do one of two things. You can either go over these with a soldering iron and try to touch them up. You know, if you have to, you can add some more solder, use some solder balls, whatever. The main thing is to get any of the ones that are not ground separated from each other, because that's going to cause some problems, obviously. The other option is that you can just completely remove the sections that you have faults in, and you can put solder paste on, you know, just reapply it and use hot air or something to melt those. You don't have to put them back onto the platform. So that's entirely up to you. I find that usually I can get these separated just using a soldering iron. It will take me a minute sometimes. Since the time that this video was made, I've actually got a little bit better at this, so I don't generally have to go through this process, but there's a good chance this is something you may run into the first few times that you do it. Right, now that we've got that all cleaned up and I've inspected it vertically to make sure that these are all about the same size, we'll go ahead and put the top board on, turn on our preheater, and then one of the tricky parts here is just kind of aligning the boards. It's not really that difficult, but you do want to look at it from different angles and make sure that everything is matching up. And once you feel like it's aligned pretty well, and by the way, we do want to add flux to here. For some reason, I did not get that in the video, so we are going to put fresh flux all along the entire perimeter and anywhere that we have these solder joints. Once you do that, we get it on the preheater, turn it on, and you'll see here if you move the board and it doesn't bounce back into position, then you haven't got enough heat quite yet. So I do keep an eye on this. Look out for solder that is bubbling, because that's, flux that's bubbling, because that'll give you an indication that the heat's approaching the point where everything's going to melt. And you'll see shortly here that after we leave it on, it is about, oh gosh, probably about 3 or 4 minutes, probably about 3 minutes, maybe even less actually on this one, before everything is ready to melt. In any case, you really can't just time it. You've got to pay attention to what's going on the board and make sure that you see it melt, and as soon as you see that little bounce back when you nudge the board, it is time to turn off the heat. Now I am going to speed this up a little bit, so this is a time lapse you're watching. It does take a little bit longer for this to complete the process. I'm going to give the board a little nudge. You'll see it bounce back into position, and that means it's time to turn off the heat. Okay, so we've got this thing all put back together, and when we plug it in, it definitely powers up. You can see it is also charging. We've got touch, display is working, power button. Only thing is with the passcode, there's not a whole lot that we can test. I'm not getting any Face ID error messages, no SIM card involved, obviously. We can actually test the flashlight and see that that's working. I don't expect any issues with this phone. So we should be good to go.